Okay, fams, let's solve together the very final question we're given as a take home in our previous lesson on projectile. So right here, we have a stone is projected from the top of the tower horizontally with a speed of 4 meters per second and lands on a level ground at a horizontal distance 25 meters from the foot of the tower. Calculate the height of the tower. And there's something I want to note. This very question looks quite different from the previous questions we've solved. Now, one thing I want to take note of is this. This body was not projected, or the stone was not projected at any angle. Unlike other ones walked on, the body was either projected down at a given angle, let's say at a given angle against the horizontal, or the body was projected up like this. But this very question, the body was just projected horizontally like this. So it's quite very complex, but very simple. So right here, this was done on the top of a tower. It was done from the top of the tower like this. So somebody stands on this tower and throws a stone like this. So the stone was not thrown down at any given angle against the horizontal. The stone was not thrown up. The stone was just thrown horizontally, just like this. So this was going to happen on a physics note. So it's going to go, the stone will go, it can't go forever because of the fact that we have gravity to go for some time, cover some distance. Then gravity sends it down. It gets somewhere around this place, gravity sends it down, then it comes down like this. So it can't keep flying forever. It can't keep moving straight like this forever. So it gets to this place and it drops down to this place. So the fact is this, we have a well-known fact. Now this is a well-known fact. At this very point of projection, we only have initial speed along the x-axis, which is given as 4 meters per second. So at the point of projection, initial speed along the x-axis is 4 meters per second, while initial speed along the y-axis is 0 meters per second. So the body did not move along the y-axis. The body only moves like this, thrown straight, flies or travels for some time like this in the air, covering the distance on the ground axis, as on the y on the x-axis. Then before it bends down and hits this place. So from here to here, there was no major movement along the y-axis, no acceleration along the y-axis. So we had a movement along the x-axis, even though there was no acceleration along the x-axis also, because the speed we had at this very junction, is the same speed we have at this very junction. There's no acceleration on the ground. So now we are asked to get what are we asked to get? We are asked to calculate the height of the tower. Now we know the initial speed to the 4 meters per second along the x-axis, and the final speed also along the x-axis is 4 meters per second. As simple as that. So it's very simple. We can use our trajectory formula, but there's something I want us to take note of: the angle of projection. Now, since this body was not fired at an angle, at any given angle to the horizontal or vertical, either up there or down like this, it means the angle of projection is 0 degrees. That's what it means. So just note that. The body was not thrown like this. It wasn't thrown like this. It was just thrown straight. So the angle of projection is 0. That's angle of projection. So angle of projection is 0. So let's use our formula. The height of the tower is what we are looking for. We are looking for distance along the y-axis. So that's what we are looking for. So distance along the x-axis is given already. The body hits this place, which is 25 meters away. 25 meters away. So this 25 meters away. We're looking for this. Angle of projection is 0. And we have this initial speed along the x-axis is the major initial speed. We don't have any initial speed along the y-axis. So this is major initial speed just along the x-axis, 4 meters per second. So our formula, distance along the y-axis, is distance along the x-axis tan theta, which I have here, then plus 1 over 2 gravity, distance along x-axis is part 2 over initial speed squared along the x-axis, cos, that's why we have cos theta. Don't forget the angle is 0. So what do we have? Distance, you're looking for distance along the y-axis. So distance along the x-axis is 25 times tan 0, tan 0 is 0, tan 0 is sine 0 over cos 0, sine 0 is 0, cos 0 is 1. So plus, don't forget this body falls down in obedience to gravity. So gravity is positive, 1 over 2 times plus 10 gravity. The distance along the x-axis, which is 25 meters, we have that 25 meters, 25 raised to the power of 2. Initial speed is 4 raised to the power 2 times cos 0 raised to the power 2. Cos 0 is 1, that's 1 raised to the power 2, which is ordinary 1. So 2 year 1, 2 year 5. So distance, so you're going to see times 0 is 0. So 0 times this is gone. So we just have 5 out here. 25 raised by 2 is 625 over 4 raised by 2 is 16 times 1. Because 0 is 1, 1 raised by 2 is 1. So let's punch in our figures in our calculator. So right here we have 5 times 625 divided by 16. We have 195.31. So the distance, the height of the tower is 195.3 meter. That's the height of the tower. As simple as that. So this is a very solution for the very final question. So we're done with everything. So at this very point in time, we'll be drawing the curtain completely on projectile. So at this very point in time, we should be pros when it comes to solving questions on projectile. No matter how complex the question is, you should know what to do, regardless of how complex the question is. So we're drawing the curtain on this very lesson. So if you found this lesson helpful, I'd love you to subscribe to this very channel at EduMosaic, and also follow me on Facebook at Revelation Hub. Please share this lesson also. See you in the next lesson. Thanks.